Hello, so we have started to look at solving simultaneous equations. What we've looked at so far is just using graphs to find the point of intersection of the equations on the graph. And that's one way of solving these equations. Eventually what we're going to do is use algebra to solve the equations. But so far we've just been using graphs. So an example that we have been using So the example we're given here, we've got two equations. One of them has been given the name m, it's just a name, and the other one has been given the name n, again just a name. The first one says 2x plus 3y is equal to 12. So whatever the x coordinate is, if you double it, and whatever the y coordinate is, you triple that, add your two answers together, you're always going to get 12. Any pair x and y that match up like that will be on that line. And if they don't match like that, they won't be on the line. In this equation, we've got x minus 3y is minus 3. So this says whatever x value we have, if we take away 3 of the y values and end up with minus 3, then that xy pair belongs to that line. And if you don't end up with minus 3, it doesn't belong on that line. So what we want to do is put these two lines on the same graph, the same axes and the same scales, and see where the two lines intersect. So we're going to try to find which value or which pair x and y will fit on this line, but at the same time or simultaneously fit on this line. So one pair x and y belong to both of these lines. So to start by drawing the graph, we're going to draw this graph here first. Now to draw any line, we need to find 2 points on the line. So the easiest point to find, first of all, is probably the point where x is 0. So I can put 0 in here. I've got 2 zeros and 3 y's will give me 12. And I need to figure out how many y's, or which y will fit there. So which y is the partner to 0? So 2 zeros and 3 y's matches with 12. 2 zeros is 0, so that's nothing. So I've just got 3 y's matches to 12. So each y must be 4. 3 4's will be 12. So 0 and 4 belong together. 0 and 4 belong together. That pair is one of the points that's on this line. But to draw the line, remember I need 2 points. So it was easy to start with x equals 0, and that gave me the y-intercept, the point where we crossed over the y-axis. So another easy one to work with is one where y is 0, and figure out where it crosses over the x-axis. So on this line, what I'm trying to figure out is another point, and I'm going to start off, I have to put this point that I've already found on my graph. So 0, 4 has to go onto the graph. There's a 0 on the x-axis, 4 on the y-axis. That's our y-intercept. Okay, so we're going to go back to the line and we're going to try to find another point. Easiest one to find is the x-intercept, the one where y is 0. So somewhere on this x-axis, one of those x values matches up with y being 0. So if we plug in 0 here into our equation, we'll have 2x plus 3 zeros matches up with 12. So 2 x's must be 12, so each x must be 6. We get the point 6, 0. So 6 and 0 are a pair of points which belong together on this line. So we put it on the graph. So we've now got 2 points and we join them up and we make a line. So that line is that line M. The line that's got 2 x's and 3 y's is 12. Doesn't matter which point I pick on that line, 2 of the x's and 3 of the y's is always going to give me 12. So I need to do the same now with my other line, line N over here. So I'm going to do the same. I'm going to start off with when x is 0 on this line. I'm going to put 0 in there and try to figure out what y is. So 0 minus 3 y's is minus 3. So if I divide everything by minus 3, I'll get 1y is equal to minus 3 divided by minus 3, which is plus 1. So 0 and 1 is a point, a pair of coordinates that fit on that line. So if I put that point on my graph, 0 on the x-axis, 1 on the y-axis. Okay, I chose x equals 0 to help me because it's easy to work with x is 0. I could have chosen any point I liked. Like for instance, I could have chosen if x was 1. If I put 1 in there and then figure out what y is, then I can go, well, if 1 here and y is somewhere here, and I can plot that point. It's just easy to do 0, x is 0. So it's easy as well to get the next point. I'm going to use y is 0. So y is 0, plug that into my equation, substitute it in. I've got x minus 3 nothings is nothing, so x is equal to minus 3. So I've got the point minus 3, 0. I need to put that on my graph. There it is. I've got my 2 points for this line, so I can join them together to draw in the whole line. So that green line there is that line N. So what I'm looking for is which point is actually on both of those lines at the same time. So I'm looking for the point of intersection. Where do the lines cross over? You can see they cross over at the point 3, 2. So when x is 3 and y is 2, I get the point of intersection. So what that tells me is that that point 3, 2 has to be on both of those lines at the same time. So if I substituted 3, 2 into here, I should get 12. And if I substitute 3, 2 into here, I should get minus 3. It's an answer to both of those equations at the same time. So we should really be checking our answers. So let's check with the first equation. I want to put x is 3 and y is 2 into this equation to see does it work. So substitute in x is 3, y is 2, then do my sums. So 2 3s is 6, 3 2s is 6, and 6 plus 6 does equal 12. So that's correct. Do the same now with the other equation. Check the point 3, 2 in the other equation to see is it also a solution for that one. So the other equation, substitute in, instead of x I've got 3, instead of y I've got 2. Do my sums. Well, 3 is just 3. Minus 3 multiplied by 2 is minus 6. 3 take away 6 is negative 3, so that's correct. So what I've done here is I've verified my solutions to my simultaneous equations. So the bit we did here first of all was drawing the graphs. Then once we'd drawn our lines, we found where they overlapped and we got our answer. 3, 2 was our answer. And the last bit here, this is just checking our answer to make sure that it's correct and we haven't made any silly mistakes. So we've checked our answer, we've verified our answer. And that's what we're going to be doing in the next exercise on our course book.